Hey guys, David here and welcome to another video. This is another workshop video and you have caught me in the middle of an upgrade to my Logic Killerbee CNC. In this video I'm going to take you on the journey of me trying to figure out proper dust collection for this machine. This has been a long time coming. I had this little old thing that I designed when I first kind of built this machine. This never worked. I'll talk about that later. And I've just been using my enclosure with no dust collection, and this kind of works, but fine dust still gets everywhere and the enclosure is completely covered every time I run a job. So it's time. I'm upgrading the rest of my shop's dust collection as well, so this is the perfect time. So let's take you a bit on a tour of what I've done so far and what still needs to change. But first of all, I want to give a big thanks to PCBWay for sponsoring this video. Not only do they make super high quality PCBs for a very affordable price, they also have manufacturing services like all kinds of 3D printing and CNC machining. You can get stuff 3D printed from metal, all kinds of resins, super clear stuff, and all of that for a great price. You can just upload your files to their online quoting, you get an instant quote and get on with your project. So if any of that sounds interesting, make sure to go check out PCBWay, link down below. Now when we talk about dust collection, there are many different ways that you can approach that on a CNC. Most people don't really have an enclosure on their CNC, so having some sort of dust management is essential if you're cutting, well, basically anything. A very common thing to start out with is just a shop vac. Just happen to have mine sitting down here, and I tried that at first as well, and you can build a little dust hood like this one that makes sure that all of the chips is captured. And on my very first CNC I used that sometimes. It sort of works. But the main problem with a shop vac is that while it has a lot of suction power, which is great if you're vacuuming the floor or trying to clean something else, it does not move a lot of air. And it's kind of not necessarily something that we think about. There's two kinds of kind of suction things. One is very high suction, but not a lot of air movement. So like a shop vac, for example, or I don't know, a vacuum pump. They can create a lot of suction but without moving a lot of air. On the other side of the spectrum, we have something like a dust collection system, like I just installed here in my shop. Those move a lot of air, but not at a very high suction level. So if the path is obstructed, then those machines don't really work that well. So they would not work with a very thin hose like on a shop vac. But on the other hand, the shop vac can easily work with a thin hose without losing much of its power. But the problem then for dust collection is that usually the shop vac does not get that close. And there is a lot of air from around that can enter, and then you don't actually suck up the chips. So that is what these dust shoes try to mitigate. They basically build a little box around the cutter, and then you don't need a lot of air movement if all of the air needs to come from where the cutter is. But the problem with these is that, well, it's a CNC, it moves around. It moves left to right, which is fairly easily accomplishable, but it also moves up and down. And that's where the issue is. Unless you have a very sophisticated dust shoe mechanism that also adjusts itself independently from the cutter head, this will move down when the CNC moves down, and then you have all these bristles that are in the way and push into your material. And, well, this was the downfall of this design. It was just too small. If you move down, all the bristles would come inside, touch the cutter, and, well, game over. So this never worked at all. But if you design this slightly larger, then this could work, but you still have that same issue. So what you end up doing is that you kind of set it relatively high, and then it kind of pushes down a little bit of the time. It's kind of slightly above a little bit of the time, which is a good compromise, but means that a lot of the time you lose suction. If you have a dust collection system, which you don't have to have something quite as elaborate as I have here, not to say that this is all that crazy, there's way more crazy systems out there, but you can, just for a couple $100, get a fairly entry-level dust collector. They'll do the job for a CNC and they will move easily 5 to 10 times as much air as even a high quality shop vac. But with these systems you cannot use a little shop vac hose. If you add one of those hoses to it, sure, it'll still suck a little bit at the end, but you'll quickly lose 80% of your airflow if you attach a small hose like that. Most of my shop is plumbed with 100mm, so 4-inch ducting, and that does a pretty good job of being small enough to still be somewhat manageable, but not lose a whole lot of airflow. Now going into the CNC, doing also 100mm would be great, but since I have an enclosure, and this enclosure is designed fairly close to the machine itself, I didn't want to lose too much travel, and 100mm hose was just too big. So what I did is I stepped down to 75mm hose for inside of the CNC. But let's quickly back up just for you guys out of interest to show you my system and some of the upgrades I did. If you haven't seen my workshop tour that I did recently, go check that out. Kind of showed you the system there, but then I just had the dust collector with a flex hose that I just kind of had to manually move around. But now some of the parts that I ordered came in, and for one I replaced just the back filter that came with the dust collector with this really nice canister filter. And not only is this filter a lot finer, meaning that a lot of the very, very fine dust that you don't really see but still gets in your lungs is now getting filtered out. It also has more surface area, which means that there's less restriction to the airflow, so there's actually more performance out of the dust collector now. And then the other thing that I did is I just ran some PVC ducting and some metal ducting that I still had lying around, and a couple of blast gates, and that way I have my bandsaw, my drum sander, as well as my CNC always hooked up, and I just open and close the blast gates to choose which machine gets extracted. This just makes it a whole lot easier to switch back and forth between them without having to move stuff around. Then arriving here at the CNC, I have just a 100mm port on the outside, just a 3D printed thing, which then adapts to a 75mm port here on the inside. And then I have this 2-meter flexible hose here. I got this off of AliExpress. The quality is not great, but the price is good. And well, it is crazy how expensive flexible dust collector hoses get. But looking at expensive and cheap ones, I do understand it. But still, I'm not willing to spend 50 or 100 bucks on a hose. There's two puzzles left to the game. One is the dust shoe that I've already mentioned before, but we'll get to that later. And the other puzzle is somehow this hose needs to be managed. You cannot just plug it in here, leave it lying around. Because when the machine moves around, well, it has to move around as well and not crush itself and get caught on stuff. If you don't have an enclosure and a lot of room, you can easily just kind of the center over top of the CNC, attach it loosely, and then it can just hang from there and move all around. That's a good solution if you don't have an enclosure and decently high shop space. In that case, you can even use 100mm hose and you're perfectly golden. In that case, that problem is solved already. For me, with an enclosure, that's not an option. So I had to just kind of snake this around in a way that moves with the machine. The way I did this basically was I attached it here at the end with just some zip ties, attached it on the other end, and tried to figure out how can I move it, move the CNC around, kind of how can I manage it. The basic idea is to do it the similar way as all the cables are attached, but without needing quite as much room. Since, well, for one, this is large, but at 75mm, I cannot route it everywhere that the cables are going. And on the other hand, I want to keep this run as short as possible. I got a 2-meter hose, which for this machine turned out to be just perfect. But you also don't want to make this hose too long, because too much flex hose also adds more restriction and gives you less airflow. In the end, what I settled on is just kind of having this little post here in the back that makes sure that it's at the top so it doesn't get pinched on the bottom, and then just like an S in the fully retracted position, and this then extends all the way to the end. And here it is attached to the end here, and then on the y-axis there's not a lot of travel, so I was able to just have it hanging there, and it's going like that. I moved around the machine a bunch, and this seems to be working. So that problem is solved for me as well. I'll of course replace these zip ties with something slightly more permanent at some point, but for now this works. Then the final challenge, and basically the biggest challenge as well, is the dust shoe. I already knew I had to go a lot bigger, and I also knew I was not going to nail this first try. So instead of designing something and then 3D printing it and designing with magnets and everything, I went back to the grassroots, started very simple and just machining it out of some MDF. the first attempt I did, well, I made the walls too thin and the thing blew up while milling. That did not work. Back to the drawing board. Just make the walls a bit thicker, and this printed, well, not printed, this cut out fine, and then while assembling, well, it's MDF, it was gonna split anyhow. It split a little bit, but I was able to kind of screw glue, nail it together, and get it working. This is what is on here now. And compared to not having a dust shoe, which cut some of the dust, as you could see while cutting this piece, it still left a lot of the dust there. And here I have so far not cut anything with it yet, but I just kind of moved back and forth across the table with the tool like 5 millimeters above the table, and it perfectly cleaned off the mess that the previous operations left. So there's definitely a lot of promise. But this design is very much a first iteration and still has some issues. For one, the back is open, but the way that this machine works is really not a good way to wrap it around the back. So I'll probably leave it like that and either just add a little bit of a curtain here in the back, or maybe it doesn't even need it, since the dust port is on the other side. It can, like, any air that it pulls from back here will pass the tool. So since I have a lot of air movement, this might be fine. If you're using a shop vac, you definitely want to close off the end as well. But in this case, it might be fine. Then the other issue is, this is slightly height adjustable. It mounts back here to the V-slot extrusion from the Z-axis plate. So this gives me height adjustability, which is very important. That way, depending on how long the tool is, I can make sure that the tool is just ever so slightly below the end of the bristles. This is also another issue with this one. It didn't really have any height adjustability. Right now, these are just bolts. In the end, I will probably use thumb screws here, so it's a bit easier to adjust. But the issue is that to change out the tool, I basically have to take the entire thing off. So that means loosening these bolts out completely, dropping the T-nuts in here, and taking it off just to change out the tool. That's big pain and will probably mean that I will never actually use this. So I need some sort of access port here. Not quite sure yet how to do that. Another great thing would be for this hose to be easily removable. That way I can detach it and just clean up around all of the areas that some dust inevitably got to, or if I was not using the dust collection for an operation. For example, if I'm using a tiny tool, I'll probably not be using the dust collection. It just gets in the way and it's not really necessary. Then I can detach the hose here and clean up in the end. So, well, I'm gonna go figure out these two issues. Then we'll make a final version of this, and I'll see you back. And here we go, 2 revisions later, and I think we have a winner. Now, it is still basically the same design as before, but what I did was, instead of having one plate that has both the brushes and is attached to the router, I have 2 plates with magnets And that allows me to take it apart, remove this bottom part with the brushes that is in the way, then I can change out my bits, I can change the height here, and then just clip this back in place with magnets. Now, I knew that magnets was a very common solution to this problem before. I used it in my last design. I just wasn't sure if it was strong enough here, but after doing some Googling and looking at other solutions, basically everybody uses magnets for this, so I have confidence that this will work fine. And it actually locates in the back against the extrusion, so like here it cannot slip back and forth, and just here in the front ever so slightly, but you basically have to pull down to take it off. So I think the magnet's going to be plenty strong. And this height adjustment also works great. It is like has a bit of range up and down, maybe like 30 millimeters in total, but like that's basically all I'm gonna need. Like most of the tools stick out roughly the same amount. Right now I have it set to where it is just barely higher than the surfacing bit I have in here, and that should basically have the brushes almost touch the wood when I surface it. And I guess that's the real test, since that is the tool that creates the most wind and the most fine dust, which I really want to capture. Now, right now I still have some bolts in here because my thumb screws that I have for M5 are not long enough, so I have to go to the hardware store, get some longer thumb screws, and to be able to use this hose to vacuum up the rest, I will get like a quick release hose clamp for this connection here instead of the zip ties, and that will allow me to do that. I considered making this 3D printed piece here with magnets as well to attach here, but for one, that has a chance of falling off, and two, that leaves this big flange on here, which I'm not a big fan of. So I think this solution will work fine, or otherwise this piece just bolts on, so I can very easily 3D print a new piece here. Also, if you were thinking why didn't 3D print the whole thing, I have the Rhetoric VCore 3.1, which is a pretty fast machine, and like printing this flange here took about half an hour, which is quite decent. But in the same time, I was able to machine an entire revision and assemble it of the wooden parts. So by 3D printing every revision, and for a bigger piece like this would probably take, I don't know, 5 hours or something. I could do maybe 2 revisions in a day, and here in a time span of maybe an hour or two, I was able to arrive at my final revision. So sometimes 3D printing is great, and sometimes, although it's fast, it's not fast enough. But with that, I think the only thing that is left to do is to cut some material and see how it does. So first I'll make sure to clean everything off to have a fair starting point, and then we'll surface some boards. Maybe we surface the spoil board, so it doesn't really need it, but maybe I'll take a skim off of it as well, and just to kind of show you how well it is working. Well, here we go. That's the aftermath. I cut this entire neck. So first surfacing both sides of the flat billet with the big flat cutter. That created a lot of the fine dust that you can see. Basically all just came out the back there. And then I adaptive cut all the material away and then use the ball and mill to finish it. And that's what, like, some of the bigger chips here, those would be from the adaptive. And then some of the other, like, medium-sized chips will probably be from the ball and mill. You can definitely see that here on the back, where it is open, there is sometimes chips flying out. So basically, whenever the cutter is throwing them with a lot of force that direction, then they do fly out and don't get sucked up. But either when they're not getting shot out that fast, or if they're smaller, then they all get sucked up. And basically all of the fine dust got sucked up as well. So by adding a little dam back here, which does impede like the height adjustability, that's why I didn't do that so far, that should probably get rid of 90% of the very small amount of chips that is left. Like, this is already basically nothing. That's what would be left over after I clean up after cutting it. Maybe I have a picture that I can insert of how the CNC looks without dust collection after cutting. The only other downside is that you can't see a damn thing while you're cutting. I mean, it's obvious. I was gonna make the wooden piece here also out of plexiglass, but the piece of 10mm plexi that I had was too small. So I might remake that, because you cannot see anything. And with that was plexi, you can see a lot. Like for video, it wouldn't make much of a difference. But for me, I could at least see, I don't know if the tool's broken or not, or if it's cutting in the right place. But right now, I'm just kind of flying blind or trusting the program. With that, thank you guys so much for watching. If you have any questions, leave them down in the comments. I'll also try to put a link to the Fusion file for my design here down below. Now, you'll likely have to change it a bit unless you're also using a Killerbee with a 2.2 kilowatt Chinese spindle. Otherwise, like, the dimensions are going to be different, but it can give you a bit of an inspiration starting point. That's it. Thanks for watching, and I'll see you next time.